Okay, this is problem 1048, and what I like about this is the process. Okay, because what they do is they decide, well, if one variable gives us this, what does two variables give us? And so they do a multiple regression with it, and you can see that it doesn't necessarily improve it. So in our first one, we've got two independent variables, the number of purchase orders and the number of suppliers. And the R square is 0.64. R square is 0.64 in both of the regressions. The second regression has purchase orders, suppliers, plus the purchasing dollars. Okay, and the Durbin-Watson statistic is the same, but what's wrong here? Let's see, something's different. Yeah, so what we've got, though, the other thing they've got are coefficients of correlation between the variables. And that's what's happening, okay? The variables are really related to each other, so that's not going to give you a really clean result. In terms of economic plausibility, all three are, maybe the purchases, but the number of purchase orders and the number of suppliers, definitely makes sense. This is after the regression. And for goodness of fit, the first regression is not a good fit, mostly because 4 and 5. The R square is the same. Well, we can look at the t-values on that. The on the number of purchase orders, it's 2.19 here, and on the number of suppliers, it's 1.99. So neither are significant or even close to significant. Okay. On the specification analysis, the Durbin-Watson statistic is of 1.91, indicates that the assumption of independence is not rejected. Okay, so the fourth regression is consistent with the findings in 1047, that both the number of purchase orders and the number of suppliers are driven by purchasing department drive purchasing department costs. Okay, so 2, 3, and 4 still satisfy all 4 criteria in the text, but 4 has the best goodness of fit, 0.64 for the regression, compared to 0.43 and 0.39 for regressions 2 and 3. Okay? And what's really important is that it's plausible that would make sense, that this is the way that this would be okay. Now the last one, regression 5, adds purchasing dollars. Okay? How many are purchased to the 2 other independent variables. And that has a t-value of minus 0.01. Where is it? 0.01. And that means its slope coefficient is insignificantly different from 0. Okay? So the R square in regression 5, 0.64, is the same, implying that the addition of a third variable didn't add any explanatory power to it. Okay, it didn't help anything. If this had added some information to the relationship, then this R square would have increased. Okay, so we would probably recommend, you're better off to keep it simple and cleaner, because the more that you add in, the more problems that you have, like multicollinearity. Okay, and it's as they say, it's frequently encountered in cost accounting. And what we do is we run a statistic of variance inflation factors, and they can show you if you've got a problem. Okay, and what multicollinearity does is it gives you problems with coming up with a model that fits really well. Okay, so these numbers here are from the multiple regression. Okay, this should be maybe centered or something like that. Let's see. T-value in multiple regression. Okay, and this is the t-value here from simple regression. Okay, so 2.19, 2.46 for the number of purchase orders. And that the decline in the t-values in the multiple regressions is consistent with some multicollinearity among the independent variables, but it's not really that strong. So the higher the t-value, the greater the evidence against the null hypothesis of no relationship. Okay, and when would you use these Regression results would be useful in cost management decisions, in purchasing policy decisions. We could establish an internal charge maybe within the stores to make them more or less responsible for what their expenses are, and also an accounting system design, maybe to discontinue the current design. Okay? All right.